Okay, let's have a look at the mechanism for the electrophilic addition of either a halogen or a hydrogen halide to an alkene. Before we start, let's just work out what halogens and hydrogen halides are. So halogens are elements that we find in group 17 of the periodic table. For example, fluorine, which exists, in fact all of them exist as diatomic molecules. So we've got fluorine, chlorine, bromine, iodine. And noted here, they're all non-polar molecules because they contain identical atoms bonded together. Secondly, we've got the hydrogen halides, and this is simply a molecule formed between a hydrogen and a halogen. So some examples of those ones, we've got hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide. And because we have an electronegative element bonded to a hydrogen, these are all going to be polar molecules. And that will be important a little bit later on. So let's have a look at the mechanism for this electrophilic addition reaction. And to start with, in our example, we're going to look at ethene, which is my alkene, and we've got a molecule of hydrogen chloride above it. So the first thing to note in most mechanisms is that we want to have a look, see if we can identify anywhere where there might be some kind of negative or partially negative charge, and also somewhere where there is a positive or partially positive charge. So in this example here, well, we can see in my alkene I've got a double bond, and that double bond is probably going to be an area with fairly high electron density, acting as a kind of region of negative charge. And on my hydrogen chloride molecule, it's important to note that that molecule is polar. My chlorine, which is much more electronegative, I could represent with a little delta negative to show the negative side, or partially negative side, and my hydrogen, conversely, is going to be the partially positive side. Now, as soon as we've identified an area of electron density, which we said was our double bond in the middle there, lots of electrons, and we've identified somewhere with a partially positive charge, that's probably going to be the start point for our reaction. So the first step of my mechanism, if my area of electrons are attracted to that partially positive hydrogen, we're going to need to draw a curly arrow that looks something like this, where we're actually going to be using a pair of those electrons from the double bond to form a bond with the hydrogen. So in this case, we might remember from the title, this is an electrophilic addition reaction. And in this case, it's my hydrogen on the HCl that's behaving as my electrophile, because it's being attracted towards electrons. It's kind of electron loving. Now, if my hydrogen has just had a new bond formed with it, and hydrogens can only have one bond, then the other bond to the chlorine is going to have to break, and both those electrons are going to go back to the chlorine atom, which will then, because it's gaining an electron as well as the electron that already belonged to it, it's going to end up being a chloride ion. So if this step occurs, let's see what we've got left over. Well, I've added a hydrogen to the carbon using electrons from my double bond. We've got a chloride ion left over, and the other carbon on the other side of my double bond, which has just lost one of its electrons, is now positively charged. And any time we have a species with a positively charged carbon on it, we call that a carbocation, and in this case it's an intermediate, because this thing is going to exist, well, for a little bit of time until the next step in my mechanism happens. So because I've got a negatively charged chloride ion and a positively charged carbon, they're obviously going to be attracted to each other, and because we always draw curly arrows from electrons, we're going to form a new bond from that pair of electrons to my carbon. So what do we produce if that happens? Well, we're going to end up with this molecule here, where I've now formed a new bond between the carbon and chlorine. We could name that product. It would be chloroethane. I don't need to put one chloroethane because it's the only place it can go. And overall, if I look at my process, what I've done is I've added a hydrogen chloride molecule to the ethene molecule, which is why this is known as an addition reaction. Specifically, as we said in the first step, it is an electrophilic addition because it's that partially positive hydrogen which kind of kicks our process off. So that's a hydrogen halide being added to an alkene. Let's now consider the other possibility, as mentioned in the title, which is going to be adding a halogen to my molecule. So in this case, the mechanism is actually going to be pretty much identical, but we need a little bit more clarification of why the first step happens. So again, I've drawn my alkene, I've drawn ethene in this case, and you'll notice that I've drawn my chlorine molecule on a bit of an angle. And the reason being because it's a non-polar molecule, so actually at the moment there's nothing partially positively charged. However, as my chlorine molecule moves close to that double bond where there are lots of electrons, what I will actually find is that the electrons in my double bond will repel electrons in my chlorine molecule, meaning that when pushed to the far side I end up with a partially negative chlorine, meaning the closer chlorine is partially positive. And again, as soon as that step has happened, we now have an electrophile. We've got something with a partial positive charge in this case. And we're going to see exactly the same mechanism as before. So my halogen molecule has been polarized by that electron density, and then I'm going to see my first curly arrow go to the chlorine. The other bond therefore must break, and if I work my way through the process, we form again a carbocation intermediate. My chloride ion floating around is going to be attracted to that positive charge, and this time similar product, except now, in fact I noticed a mistake there. That of course should be a chlorine, not a hydrogen. So we've ended up with a slightly different molecule. In this case I've got 1,2-dichloroethane, and again it's an addition reaction because I've added a chlorine molecule to an alkene, in this case ethene. And that's pretty much it for those mechanisms. They're identical. Just that first step when we're talking about a halogen that we need to recognize, the bond is polarized when it moves close to my double bond. And that will do it for today. Hopefully this video was of some help.